Live from New York, it's Ask an Engineer.
Hey everybody, and welcome to another week of a wonderful Wednesday Ask Engineer. It's me, Lady Ada, the engineer, and with me is Mr. Lady Ada, and we also have the on-air sign.
That's right.
Proves to you that we are on the air and we're live, coming to you from Adafruit headquarters in downtown Manhattan. We're broadcasting live from the warehouse. We've got all those boxes behind us full of goodies. An exciting show for you tonight.
That's right.
Tell them what's on tonight's show.
On tonight's show, the code is Mouser.
Okay.
We're going to talk about why the code is Mouser and more.
It's because of the enemy in Super Mario Brothers 2.
Yeah. Show and tell, all the people around the world who show and share their projects. We're going to talk about that. Pack the mailbags and stop by. Adafruit jobs board. Time travel. Wearables. 3D printing. Raspberry Pi, new products. We're going to answer your questions. We're going to have a trivia question, all that and more on, you got it, Ask an Engineer. That's what we're doing here.
We're doing it.
We're doing it. Okay. So.
We love doing a weekly live show every week.
Just a programming note, we are off next week, so there is no show and tell and no Ask an Engineer. There is Wearable Electronics with Becky Stern, though. Mm-hmm. Depending on some things, I might maybe put up another video or something. We'll see.
We'll just have the arduino in front of the American flag playing for an hour.
Yeah, I'll get Rumblefish to send me a copyright notice that they own America the Beautiful again, because that's what I really like spending my 3rd of Julys on, fighting copyright battles.
Yay! Well, that is what makes us American, right? We love to nerd out about the law. We have like a lot of lawyer friends now. Anyways.
Yeah.
Okay, see the show.
All right, so more stuff. Code Mouser, a little housekeeping here. 10% off in the Adafruit store all the way up to 11:59 p.m. Eastern Standard Time tonight. A little bit of housekeeping too. Don't forget, $200 or more for UPS ground. Also, if you're in New York City and most of Manhattan now, you get same-day delivery. You just have to order by 11 a.m. and it'll arrive by 5. Drone delivery is coming up. I'm not kidding.
We're working on it.
But right now, this is as fast as we can do. We had a person on the show and tell that we sent them a show and tell sticker, and they got it in like less than a week. We ship so fast.
We're so fast.
Yeah.
And you even post the stats every month.
We post our shipping stats every month. I would encourage other companies who ship packages for a living, especially if you ship over 20, 30,000 a month like we do, post your stats up. Just post them up. No biggie. No biggie. No biggie. Okay. This is the last week that we're doing the coloring book. We got through 26 weeks. 26 weeks. So Lady Ada's coloring book, R for Robots. We did A through Z. And tonight, Z is for Z-axis.
Look, Z is a tough one, okay?
Yeah. So,
like it's like Zelda, and it doesn't really fit.
Yeah.
And then Zener diode doesn't really make any sense either.
Yeah.
So Z is for Z-axis.
Z is for Z-axis. And here we have a RepRap and a Formlabs and a MakerBot. And so Z is for Z-axis. We started this coloring book like 2 years ago. A lot's changed.
There's a lot more 3D printers now, but at the time this was kind of
what was going on. So that's
that epic Z-axis.
Yeah. All right. So next up, show and tell.
This is my part.
It's your part.
This is where I do the thing.
This is where you do your thing.
Yay!
Okay, Lady, who's on the show and tell?
I'm going to tell you what's on the show and tell. We had a full and exciting group of people show up on the show and tell. Thank you, everybody. I started off with Noah and Pedro from Adafruit Southeast. They showed off a couple projects that they have been working on. 7-inch monitor, HDMI monitor that they built and they said works great. And there's, I think the video is live this week in the tutorial as well. Although I can't even keep track of the videos. I have so many videos. They also finished the 3D printed chess set and they shipped it to us. It's amazing. They even had like a little video they made of the shipping process because it was so intense. They had to like wrap each metallic printed piece and ship it to us. But we're here. It's here, and we're doing a chess not competition. What's the word again?
Chess league here.
Chess league. Yeah. That's it. We're doing a chess league, and we might have some playoffs. So we're going to play with this beautiful chess set. They also have a printed D20 die that they're working on with Phil B that's going to talk. It's going to be, you're going to roll this large 3D printed D20 and it's going to say things to you. So that's a future project that they're working on. Tony DeCola has been working on getting the BNO 055 Fusion 9-axis sensor working on the Raspberry Pi. It turns out this sensor uses clock stretching, so it doesn't work natively on the Raspberry Pi, although it does work on a Beagle and Black and Arduino and all those. Raspberry Pi doesn't support I2C clock stretching, but he did get it working with UART mode, which it supports. So he showed a demo of it with like a little chess set piece rotating and talked a little bit about that process. Chris Young came by and he had his 60th birthday party, and so for his birthday, he got himself a present, and it wasn't a Ducati motorcycle, it was a printer bot, which is like way more useful and better for you.
I agree.
And safer. And he's been printing out stuff, and he showed off all of his, like, his first prints, and they're failed prints, but he's like, I learned so much. He's like, I didn't have supports on, and the power went out, and it wasn't spooled on the spool care, like all the little things that you learn when you 3D print. And he's printing a little Adabot, and it's cool because Chris Young worked on Pavre, which is a ray tracing program. So he actually gets to like now make some of these designs physical, so you can come back and show off more of these projects. Alex Hatch has been working on also 3D printed projects. He came in last week with an EMG-powered project. This week he's doing 3D printed prosthetics, and he's instead of just trying to make like hands, which he says like, you know, you can make a hand, but it's like it doesn't make sense to try to have so many degrees of motion when you don't have that much control over them. He's instead experimenting with flexible and non-flexible combined style elements to make like grippable, like gripping hands that are like, they're smart, like they only have 1 degree of motion and they auto grip. It's very interesting.
Yeah,
Check
two
it
different
out.
types of filament, and then like it was very clever. It reminds me almost of like that balloon filled with like
The coffee grounds.
with coffee
grabber,
grounds that could like pick up something. It was
The
like
gripper
very clever.
is very interesting, because he's like by doing mechanical tricks, you can make something that auto grabs when you push or hook it onto something. It'll automatically grab the thing you're trying to pick up. So I thought that was kind of neat. Being a little smart about how you can use these materials instead of just trying to replicate, tendons as they were. Greg came in again with more Armytronics and projects from his Airsoft League. He's got the helmet cam, but he also has this vest with like a Raspberry Pi built into it, and like the top of the vest flips out. And then so he has kind of like a tray in front of him, and it has this monitor with a Raspberry Pi, and it shows him the GPS locations of all his Airsoft competitors or contributors or people on his team. And he's using XBs and GPS to track them. So this is like super cool technology going on here. Adam is a new maker who's shown up, and he got his box of Adafruit goodies today, and he's building a room detector with a PIR sensor and a lock and an RF remote. It's really a cool project. He has this beautiful desk he's working on, and he's like totally like got a sweet area in his room for working on electronics. So I'm very jealous of his clean desk. And then finally we had Marcel, who has a geared stepper motor set up for his CNC. He tried to use a standard sort of like NEMA 24 or 21 or whatever, 23. I don't remember the number, 22X NEMA stepper that are used for 3D printers, but because he's actually moving like a CNC platform around, it wasn't strong enough. So instead of getting another type of stepper motor that's stronger, he's like, I don't want to buy another stepper motor. So instead he CNC'd out gears, and he geared it down so that he could have more precision and more torque on his steppers. And then he cut out of acrylic and copper-clad PCB. He made a little like LED nightlight that as the show and tell sticker, just like the logo here, and it looked really cool. And so that's
really
neat.
good job.
Yeah, he got a little factory. He can like cut plastic and PCBs, and then he solders them together. So it's kind of neat.
All right, lady, how do people get on the show and tell?
If you'd like to join those cool people and us, the cool people, you can show up on our weekly show and tell. We're not going to have one next week, July the 22nd, but we'll have one every other week after that, Wednesday, 7:30 p.m., the show and tell. Go to our Google Plus page at plus.google.com/plus Adafruit, and look for the comment thread where you have an Adabot saying, hey, comment here to get out to the show and tell circle. Comment there. We'll right-click on your avatar if you're not a spammer. Add to the show and tell circle, and you'll be invited to show off your maker, hacker projects, electronics, crafting, cosplay, and costuming. retro technologies, just like cool mechanical things, any kind of neat thing that you want to show off, come by. We're doing it for half an hour.
That's right. All participants on the show and tell get as seen on the show and tell sticker. Just email support@adafruit.com and we will send you one if you're on the show and tell. Okay, next up, Mailbag. Packet of Mailbag stops by and we get letters from you. We read them every week to our entire staff at Adafruit at our State of the Fruit meeting. We also share them with you. Hi Adafruit, you're one of the most efficient and user-friendly online electronic suppliers on the web. Thank you for the awesome products. It looks like you'll be having a fun weekend, Danny. Yay, thank you, Danny.
Hey.
Okay, next up. Job boards. So if you're a maker who has skills and wants to get a cool job at a cool company, or if you're a company who wants a maker to work for you, post a job board. This one's pretty neat this week. This one, I think, if you're in the Boston area, an education fellow at the Museum of Science. So it's moss.org. You probably know about this, right?
The Museum of Science in Boston is awesome.
Yeah.
I've been there like easily 50, 60 times.
So what you would do is deliver educational programming daily, weekly that exemplifies educational excellence and guest service, so it is engaged and excite our audience in science, technology, engineering, and math content. So check it out. It's adafruit.com/jobs. It looks like a dream job for someone.
This looks like super fun. I know some people who've done work at the Museum of Science, like the people who do the exhibits and maintain the exhibits, and it's just like they're cool people. It's super fun. You get to just like hang out with kids and like do some electronics and physics and math and science, and they need more people, especially people with like maker background. I think would be a great addition to bring that creativity to show like, hey, there's this math, but there's also like all the stuff you can do with it. I think that'd be neat.
Okay, so
it's like super like loud outside.
Yeah,
traffic time.
We're in New York.
I don't know. It's in New York.
So
we're in Times Square.
I have open source hardware news, but it's not going to end as open source hardware news. So
is that why they're honking?
That's not why they're honking. I think they're honking because they would like to go through the Lincoln Tunnel and get home. So so I'm going to kind of explain some stuff that's going on right now.
Lay down.
Yeah. So I could put this in the 3D. I could put this in the 3D printing segment. However, I'm going to explain. So I've been covering MakerBot for like 6 years.
They've only been around for 6 years. You've been covering them since the beginning.
That's right.
Okay.
So for those out there who have followed Make and everything, so I was at Make Magazine and Bree Pettis was a school teacher, and I said, quit your job and come work with me at Make and make videos. And kind of there's a lot, the rest is history. There's a bunch of things happened. But Bree and Adam and Zach went on to found MakerBot. So when MakerBot got funding, venture capital for the first time, I said, hey, Bree, I'd like to interview you. So I interviewed Bree. Make's exclusive interview with Bree. MakerBot Life, 10 million in funding and beyond. This was October 6th of 2011.
Okay. 4 years ago.
4 years ago. And so what I did is I interviewed Bree as like the Make audience. And one of the questions I asked, you guys can read the interview, does funding change the commitment to open source hardware? The funding does not change our commitment to open source. And so basically, things changed later. And as they got acquired by Stratasys, MakerBot decided to go closed source for some things. Their previous stuff is still open source, but going forward, the MakerBots were closed source. Caused some issues. It's still debated around online or whatever. Publicly held companies don't seem to enjoy open source. Unknowns, I wasn't there. I did report on it though. So what happened after that was Stratasys had patents, and they decided to file suit with Affinia, who also had 3D printers. And
this is after they bought MakerBot. This is almost like the same month.
After they bought MakerBot, Stratasys is the company that bought it. They have patents, so they started to enforce their patents. So I believe that still isn't over yet. They're still in.
No, they're still in court.
This is still going on.
Yeah.
So this was December of 2013. And when this happened, I said, well, I know Bree. Maybe I will send him an email and see if he can do anything. So I sent a list of questions. And he actually was able to send me responses. So if you go onto the magazine site and search for these articles, it's a neat look back in time because MakerBot was a RepRap-based open source hardware company. They got funding. They got acquired. They went closed source. Their parent company did patents. And that's where the story kind of drops off as far as like our interest as a company. We decided like not to buy some of the MakerBots afterwards. They had an Adafruit edition. Wasn't the only reason, but what happened after that was interesting. So MakerBot came out with a 5th generation 3D printer. And the big thing about it was the smart extruder. And the smart extruder was a solution to like all different types of filaments, and it was smart, and it would do more than just the regular kind of melted nozzle.
Yeah. It was like removable, you could swap.
Yeah.
It was like you could have different types.
Yeah.
Do different things. It would be better. Some would be better for like flex filament.
Yeah.
Some would be, I'm assuming. I don't know.
So I think everyone agrees it didn't work out. So at launch, the smart extruders didn't work out, and there was a lot of problems with them. This weekend, you and I were at Micro Center, and the 5th generation MakerBot had a filament jam. There was a lot of high return rates, and
Like 30, 40%.
more. Yeah, at least that of the smart extruders. So we kind of covered it a little bit as this was going on. They've had a change of personnel. Bree's no longer the CEO. Jenny Lawton was the CEO. Now it's Jonathan, who was formerly at Stratasys, and he's the son of the chairman of Stratasys. So this is like an interesting story. And I started out covering MakerBot as, here's an open source hardware company, and they got funding, let's see what happens. So fortunately or unfortunately, I'm kind of stuck with the story. And I kind of, because I know all the people involved, I'm leaving opinions out, I'm just putting up facts. So this week, Adafruit broke the story. We're not a news organization, but we broke the story. It's now appearing on Engadget and Hackaday and all these places. There's a class action lawsuit. The class action lawsuit basically has stuff to do with the stock price and MakerBot. So during the time that MakerBot got acquired, it's called a class period. And during that time, the stock went up, and then it basically went down. And everybody who had their pensions tied up with Stratasys.
Well, no, I think that it was when was MakerBot was acquired in 2013.
There's a class period.
But that's what the class action.
Yeah.
That's what the class action lawsuit
That's
was
what they're
covering.
saying, yeah. So
this is after they were acquired.
Yeah. So basically, the stock price went down, and then there's people who say, well, you knew the smart extruders, you knew the MakerBots shouldn't have been shipped, and you didn't disclose that to the investors, and that's why everything crashed. And when a class action lawsuit happens, the people that are bringing it to court are people like, it's like the Hollywood firemen retirement.
Yeah, I mean, kind of everyone jumps on
the
it.
mine workers of whatever, because it's their retirement pensions that are tied up into this. So
but they're all suing as one. I mean, like,
Yeah.
this happens a lot because like we talked to another lawyer about this. He's like, well, this happens all the time. So it's not always like something's going to happen or something's not going to happen.
Yeah.
These lawsuits come up a lot. What's interesting is that, they first filed the suit like a couple months ago, and they're like, well, we're just suing because the stock went down, which is like, well, whatever.
Yeah.
But then when they did an amended filing, and that's what came out a couple days ago, it got like really detailed.
Yeah.
And we kind of actually found it sort of by accident, and we're like, oh, like this got updated, and we checked it out, and we're like, whoa, it was like, it had like, not testimony, but like...
It had photos of the whiteboards from the
Yeah.
engineering engineers.
They interviewed multiple people who'd worked there,
So
they
it's
got like
pretty
a lot of
detailed.
feedback. Yeah.
And so if you're a hardware startup, it's actually about a product launch.
Yeah.
And it talks about CES, about the announcements that were made, and all the things surrounding MakerBot, because the
return rate, the yield,
Yeah.
the like what they did with support
So-
forums. It's surprisingly detailed.
So I don't really know what else to do. Like, we discovered the filings. It's 125 pages. And I'm like, well, I already wrote that there's a class action lawsuit coming up, so I may as well say, well, here's the court documents. Here you go, folks. Read them. And if you're a hardware maker, you kind of have a really behind-the-scenes look about how something shipped, when it shipped, and this idea that maybe the company knew the smart extruders were going to work out, maybe they didn't. This will all be decided somewhere else. So we're just kind of watching this happen, and it's tough because I know all the people involved, not the people that are suing, but like obviously I know Bree. I've met Jenny a few times, and I was able to try to interview Jonathan, the new MakerBot CEO, but they didn't want to go on air, and we couldn't do like a...
You wouldn't let us record or anything,
we couldn't record anything, so I had to do an overview of the meeting. So anyways, that's the story. I don't know what's going to happen next. I'm just going to... I feel like I can't stop covering it because I started out...
It's an interesting
I started
story because...
Here. This is where I started.
It's an interesting story to see what can happen because, a lot of the times, like, we find out about lawsuits that have happened to companies either by accident or because one of the companies is, that's being sued brings it up. Like, if Affinia hadn't said, hey, like, we're being sued by Stratasys, we probably wouldn't have known. It's very rare for people to, like, look and try to find this stuff. So it's kind of interesting. to see this is,
Yeah.
seeing this, especially
So-
when we've seen so much of the history of MakerBot, and we knew about the smart extruder, and we
Yeah.
we know that they were trying to push to get a new product because
Yeah.
they had to, like he said in the interview, because the Rep 2 was open source. They're like, well, we want to make another version as quickly as possible.
Yeah. So it started out as an open source hardware story because I was really curious. What do you do when you get funding? And then they get acquired, and then the parent company had patents, and then stuff shipped, and then some of it didn't work out, and then a stock price went down, and now there's a class action lawsuit. Like, this is an interesting story, and I feel like I started covering it, and I really can't stop. I'm keeping my opinions out of this. I'm just like, here's the filings. You read it.
It's actually not up to our opinion. Like
Yeah.
they're trying to get a jury trial.
Yeah.
I don't know if they'll. I mean, it's not clear if
So-
they'll succeed, but like,
Yeah. I mean, like,
That'll be intense.
I'm sorry, MakerBot people or anyone, like, I didn't mean to break the story. I was surely by accident that I was like searching for a court document, and it's like, oh, look, MakerBot.
yeah,
Anyways,
pacer accounts kill.
okay. So in other open source hardware news, big news.
Yay, Mouser
Yeah.
and Adafruit. We
So-
love the color blue.
Yeah, so as of right now, you can purchase things at Mouser that are made by Adafruit. So let me tell you a little bit about Mouser. They are a company that was formed in 1964 by a physics teacher, Jerry Mouser, and he wanted to do electronics. They were later purchased by Warren Buffett's Berkshire Hathaway, and they have over 1,200 employees, and they have 20 locations worldwide. Last I checked in, they were something like 600 million. They're probably more now. An order that they get can ship in 15 minutes. Have 500,000 customers in 170 countries. And for you Mythbuster fans out there, you may notice that Grant Mahara is one of their spokespeople. So if you go to Mouser's Twitter, you can see that. So we're in good company. We corresponded with Grant, and he was very happy. So that's our big announcement.
Yay!
Yeah. On top of that, we have these new boxes. So these are our new Adafruit boxes. We've been working on this for a while, and these are to help us with certain types of packaging that we need to do. And the really cool thing about this box is when you open it, boom, it says Adafruit.
Oh, it does?
Yeah.
Ooh, that's nice.
Yeah. And so we're buying so many boxes, and these are cheaper than regular boxes.
Yeah, because we a long time ago we bought boxes from Uline, and then eventually we found other better distributors of packaging. But now, by the time you order this many boxes, it's like you can just get them custom made, and they cost the same amount. Because they're like, well, if we're going to make like 10,000 of these or 5,000 of these, and we have them with the barcode that we use for the UPS dimensional shipping.
Yeah.
So by scanning this barcode, it tells the shipping software that we wrote what size the box is, and so we can do the dimensional shipping analysis for UPS, because you kind of have to know how big the box is, and it kind of affects
Yeah.
the shipping costs and stuff. So this is helpful.
Okay. So anyways, that's our big announcement. Onto the Adafruit Learning System, 811 tutorials they do now.
Well, yeah, we're just banging through them.
Okay, this is the chess set. You'll see the video tomorrow. This is the Adafruit 3D printed chess set, Circuit Playground chess set. One of the coolest projects I think we've ever done. It's metal. It's 3D printed.
Yeah, it's beautiful.
It's cool.
That looks like a rendering, but it's not.
Yeah, it's real.
It's real.
Okay, next up we have the 7-inch portable HDMI monitor.
Yeah, this is the project that I was talking about. None Pedro demoed this. It takes our HDMI backpack, 7-inch backpack, and you basically make a portable battery-powered monitor. You just plug in HDMI, and you basically have a monitor that works with a Raspberry Pi, a camera, a Mac, Windows, whatever.
Okay, next up, this is the collaborating with version control.
This is a tutorial by Brennan Behrens, and this is a really handy tutorial for people who have heard about version control and Git, and they're like, what is this, and should I use it, and what's it for? And historically, Git and version control has been used for software, definitely for software and documents, and it's being used more and more for other stuff, not just source code, but like essays and law and hardware. I use GitHub to store and revise hardware, especially with the new XML EagleCAD format, or KiCad, which also has a text file format. You can easily diff and see changes between versions. And instead of keep saving multiple versions of a file, or zipping them, or making backups, you can use Git and GitHub to create backups and a version history of a long-term project, especially good for collaborating. And we also show how to create your own Git repository, use GitHub, use and install the software on Windows or Linux or Mac, which is very similar to Linux. And also how to submit a pull request, which is a common thing that people want to do. If you find a bug or you want to add a feature to one of our 480 GitHub repositories, you can make your change and then basically tell us, hey, here's the changes I made, and we can merge your updates in, and it's a really elegant way to integrate changes and make sure that we can keep up with the hundreds of repositories we have and the thousands of customers that are using them and improving on them all the time.
Okay. Next up.
Oh, this is the NeoMatrix 8x8 word clock. So if you want a word clock and you have a NeoMatrix, this is the 8x8 matrix we have in the store, you can use Arduino or a Pro Trinket and a real-time clock module to make this beautiful word clock. And I even have it here, so you can see it says 20 past 8, which is
Go the overhead?
within 5 minutes, correct? That's the problem, it's only good for 5 minutes. Yeah, sure. Oh. Hello?
Oh, interesting.
Oh, weird.
The overhead.
It just locked up.
No overhead.
No overhead. That's okay. I'll hold it up. So yeah, as you can see, it's a rainbow, and it changes rainbow pattern, and it also gets dimmer at night, so it's not too bright. So yeah, this is a really nice case that we also made, and you can see the back. It's made out of. No, that's the old one.
Weird.
Yeah. It's like trapped
Frozen
in time.
Yeah.
But here you can see the Pro Trinket and the real-time clock module, and then behind it, the matrix, and it's in this box. So it's a tutorial project. It's kind of fun because you can actually fit a word clock into an 8x8 matrix, and then you don't even have to do you don't have to do that much wiring. It's only 4 wires used in this entire project.
Yeah, I don't know exactly what to do about that frozen thing there. Okay.
Whatever.
Okay, this is the Genesis Poi, the DotStar LED persistence vision.
This is a project by Phil B. that he's been working on for a really long time. These photos are amazing, so I'd love to show them to you. And finally, these are Precision Vision stick poise, and they're made in bottle form. So there's the 2-liter bottles before they're blown into 2-liter bottles. And we use DotStar strips, which are much better at Precision Vision than NeoPixels, because you get a much smoother Precision Vision effect. So they look fantastic and beautiful, way better than it would with the NeoPixel. And we shove the trinket and a battery inside, and he shows you how to build this project. And he has a mode button, so you click the button and it changes modes, and you can have multiple graphics. Yeah. So can we show the graphics again, because they're just so cool looking?
Sure.
So you can have text. We have an American flag themed one. We have this one, which is just really stunningly beautiful. It looks like it's painted on, but it's like a rainbow pattern.
Okay.
And this is Erin doing the poi modeling. She's a fire spinner, but these are a little safer than fire. Yep. And you don't have to worry about lighter matches and propane and all that good stuff.
Next up, every week we post up some cool comics on the Adafruit comic book reading list. This one everybody probably knows, Akira.
Tetsuo!
Yeah. So if you like comic books and you want to know what everyone at Adafruit's reading, we have a pretty big group of people here.
I've never read the manga version of Akira.
Really?
No. I should, but you just got me the hip hop
Family History
by Pinsker.
Yeah,
I
believe that's his name.
I can't remember his name, but
you're gonna be busy with that.
It's awesome. I can't wait to check it out. And today, everybody we talked to today was a fan of comic books.
Yeah, it's cool. Okay,
so,
next.
It was a good day for comics.
Time travel. Look back in time. Makers, artists, engineers, hackers, you name it. They've made it. We're gonna cover it. So. Kind of a historic few days. Back in 1965, the Mariner 4 flyby of Mars takes the first close-up photos of another planet. So this was July 15th, 1965, and we sent a spacecraft to Mars to take close-up photos of a planet for the first time.
Neat.
And then what's pretty amazing that happened in the last day or so. So on the left or right, that is the previous photo we had of Pluto. This is the new photo that we have of Pluto.
Awesome.
Isn't that look at the difference?
Yeah, that's amazing.
It took 9 years to get there. And now this is what Pluto looks like, and people are saying, oh, you know what, maybe it should be a planet after all.
Looks very
It's
planetoid.
It's planet-like, and then so this is our new family portrait.
I read that they actually think that the mountains are made out of water ice. Like there's actually water ice. That's what makes on the surface. Like it's ultra cold, so it's not like you can't put it in a drink or anything. But like it's not. They thought it was maybe nitrogen ice, but it's actually water ice.
Yeah.
That's cool.
Space is a big place.
Space is a big place.
And I hope we keep this up because it's pretty neat to send. So it was a 9-year mission.
Yeah.
And it got there within like 5 minutes on schedule. No, really, of what they predicted it.
That's so cool.
Can you like the math and like sending something to space and it works and it sent back pictures? It's incredible.
Yeah.
So whoever is a young person now working on some Adafruit electronics, they might be one of the next people who build the next thing that goes to the other planets, that takes photos, that maybe helps us land.
It's going like 300,000 kilometers per hour.
Yeah, it gets going pretty fast.
Amazing.
Okay, so we got some wearables.
Okay.
So I'm going to try to catch up on some videos. So we did a teardown of the Muse, and I'm going to just roll the video.
To see this thing.
Welcome to another wearables teardown here at Adafruit. Today we're looking inside the Muse, a brainwave sensing headband for assisted meditation. It pairs over Bluetooth with your phone to guide you through a meditation session with real-time feedback on your brain's activity, followed by some stat tracking that helps you improve your calm over time. There's some interesting hardware going on inside this device, so let's see what Lady Ada has to say about the design of the circuit.
Thanks, Becky, for taking it apart. We've got 2 circuit boards in here that we've pried out of sort of the ear area. And here's a micro USB connector. We've got, probably a polarity protection diode here. This is probably the charger for the battery because it's right here next to the BAT- and BAT+ connector. Given all of these resistors and capacitors here, and it says test point, and the fact that they probably do have to test the electrodes, makes you think that this is probably an op-amp of some sort, either a single or dual op-amp, and it's amplifying the signals or buffering the signals somehow so that these can be tested during assembly and manufacture. And then we've also got a date code and Muse. That's kind of nice. And then on the back, alongside with the battery, there's this connector, and this is for that flex circuit that goes around the headband. Here is the other circuit board. So this goes on the other ear area. So let's check this out. On this side, we have another micro USB connector. There's one on either side. This one is definitely connected to this chip, which is a PIC24. So this is a PIC microcontroller. This is probably doing like all of the USB and calculation for all the sensing technology here. On the side here is going to look accelerometer. Accelerometers always have this kind of chunky look. This is an MMA 8543 or similar family, low-cost triple-axis accelerometer. You got a lot of test points here, probably for programming. Over here, it looks like there's either some sort of buck or boost converter. There's an inductor or something, a little chip, and then a switch which you can use to set it between modes. And then here's where we get to the really interesting stuff. So there's like a lot of resistors and capacitors here. And this really lets us know there's definitely analog stuff going on because there's just so many resistors and capacitors, way more than just that you would need for power filtering. And you can look up these 2 components. We've got the OPA 4374. That's a quad rail-to-rail CMOS op-amp. And then the littler chip over here is an MCP 6L02. So these are both precision op-amps. So this is the analog part that takes the sensing from your noggin and amplifies that signal and sends it into this microcontroller that does the actual digital signal processing. So let's flip over. On this side, we also have another flex connector. There's some diodes here. That's good for signal level protection. And then here we've got a big module. So this is kind of interesting. And we'll peel this off carefully to reveal the RN42. The RN42 is from Roving Networks, which is now owned by Microchip, and it's a Bluetooth Classic module, which is very interesting because all the wearables that we've looked at so far are Bluetooth Low Energy, which is kind of interesting because if you are not using Bluetooth Low Energy here, using Bluetooth Classic, then how are they using it with Apple devices because you need that certification. And so when I was looking up this chip, and I was realizing I couldn't figure out what this chip was. And that's when it hit me. This is that made for iPod or made for iOS authorization chip. And this is the MFI made for iPod. 3373959, and this is the authentication chip that this module used to let it talk to iOS. This must have been designed quite a few years ago, before Bluetooth Low Energy became popular, because if this was made now, they would definitely go with BLE. Bluetooth Low Energy is one of the few wireless protocols that iOS, Apple, and Android both support, and you don't have to go through any sort of like made for iPod or certification process. And it'll be a lot cheaper and a lot easier for them not to need to use the RN42 and this like annoying expensive chip that you have to buy only from Apple. Both of these have a little snap connector on the side, and they plug into these two pieces here. I removed this hot glue. This flex circuit connects to the two pieces, so the battery can power the circuit on the other side. So that's good for space. You have two equal lumps on either side of the ear. But this is also used as a sensor. They actually just used the circuit itself, the flex circuit itself, and plated it with what looks like silver, which makes sense, it's hygienic, and then plug that into the two circuits on either side. So this flex circuit not only is used for power and signal, but is also the sensor itself. You've got 3 reference sensors in the front, and then 2 more sensors on the side for temple measurements. But they also need to get some measurements from like sort of behind your ear. So these parts are actually conductive rubber. And they're not going to be conductive enough to light up an LED, but they're conductive enough to just get that signal from behind your ear into the circuit board. And how they do that is really interesting. So let's look on the microscope. So here we've got this flexible conductive rubber, and this is bonded, connected right up to this metal piece here, which is used as sort of also part of the electrode. And then this metal piece comes out to this part of the enclosure, and on the circuit board itself, on each one, we've got this little clip, and then when this is put together, it presses up against the metal part, which presses up against the conductive rubber, which also feels really nice, but is also usable as an electrode. It's a really interesting wearable, and I'm gonna go meditate.
For this and many other teardowns, we use the Adafruit USB microscope and its articulated stand. What wearable device should we take apart next? Let us know in the comments, and you can catch up on all our previous teardowns in the Teardowns playlist. Thanks so much for watching, and don't forget to subscribe to catch the latest videos from Adafruit.
This week we're tearing down the brainwave cat ears.
Okay, and so I'm trying to keep us up with the videos.
I can't juggle, otherwise
that was last week's.
So
Yeah, I said I wasn't going to do this on the show.
Wait, what?
I'm going to do one juggle. I think I can
Can
juggle.
you do this?
Yeah, I think I can juggle like one round of juggling.
Okay, ready?
Play the video.
And that's how we died.
Here's a simple summer project using EL wire and a little sewing to make your own bean bags you can use for nighttime yard games or your Burning Man juggling act. Let's get started. First up, stitch together 2 squares of any woven fabric with a straight stitch on your sewing machine. To make crisp corners, leave the needle down while you lift the presser foot and pivot the fabric around the needle. Stitch most of the way around, but leave an opening on one side at least 3 fingers wide. Clip the corners at a 45-degree angle and turn the bag right side out. Use a pencil or a chopstick to push out the corners, then press with an iron. Now it's time to attach the EL wire. We made a video all about electroluminescent materials and how to solder to EL wire, which will come in handy for this project since you'll probably want more than one bag. So check it out to learn more. Bend your strand at a 90-degree angle and hide the connector between the layers of fabric. Using a zigzag stitch, stitch over the EL wire, catching the fabric on one side. I'm using clear quilting thread on the top and plain thread in the bobbin. When you get to a corner, you can again use the needle as a pivot to help bend the EL wire. Be careful not to pierce the wire with the needle or you could break the tiny corona wires inside. All that remains to do is plug in the tiny inverter and fill the bag with rice or dry beans. You can hand stitch the bag shut or use Velcro tape to make it easier to change the battery. These would go great with Jason Poole-Smith's LED cornhole project, or scale it up for a couch pillow, and even try our welted EL wire for upholstery projects. We have a bunch more EL projects in this playlist. You can also find the complete instructions for this and hundreds more projects at learn.adafruit.com. There's a link in the description. Thanks so much for watching, and subscribe for more videos from Adafruit.
Okay, and don't forget, Wearable Electronic Becky's turn is coming up Wednesday, 2 p.m. Eastern Standard Time. Every Wednesday. 3D printing, okay. We have 2 videos that we're trying to catch up with. Actually, no, sorry, 3.
What?
Yeah, we have 3 because we had 3 weeks in a row where we punted the videos. So we're going to first do the NeoPixel.
But they're really short.
Yeah, we're going to do the NeoPixel Arcade.
Okay.
Here's how to add NeoPixel LEDs to arcade buttons. These are those really nice 30mm arcade buttons with a translucent look. And although they don't have LEDs built in, you can actually fit NeoPixel LEDs into the body with a 3D printed diffuser. The arcade button's very modular and actually pretty easy to take apart. Our 3D printed parts replace the stock diffuser and it's pretty simple to install. The mini NeoPixel PCB snaps into the connector piece with space for wires to pass through. So check out the guide on the Adafruit Learning System for a full tutorial. The tolerances for these parts will vary, but you can download and modify the design to fit your project. With this 3D printed diffuser, the center and the edge are fully illuminated, making a really stellar looking effect. So if you're looking to add LEDs to your arcade project, check out our 3D printed diffusers in Adafruit NeoPixels. Thanks so much for watching, and be sure to subscribe for more 3D printing and electronic projects from Adafruit.
All right.
Glowy.
We have 2 more 3D printed videos. The next one is the watch charger, and then after that, we're going to go right into the link shield.
Okay.
Yeah.
Here's how to build a wireless charger for the Apple Watch. Forget Kickstarter, you can hack your existing charger and build your own portable charger with components from Adafruit. The Adafruit PowerBoost 1000C features smart charging, and you can pick one up at the Adafruit shop. Combined with a 2000 mAh LiPo battery and a slide switch, you can build your own wireless charger. Our 3D printed enclosure is compact and houses all the components. You can download and modify the design and make it fit your project. The parts easily snap fit together and they print with no support material. You can easily fit a Qi charger inside the enclosure, and the standoffs hold the power boost and the slide switch in this compact little package. Cut and strip the cable to expose the wires. The stranded wires are going to be used as ground. You'll want to separate the wires, and you can follow the assembly tutorial on the Adafruit Learning System to connect the wires to the power boost. You'll want to tin the wires so it's easier to connect them into the breakout board. These wires will connect to the pinouts on the PowerBoost 1000C. We'll use heat shrink tubing to insulate the ground connection so it doesn't short anything out. Silicone coated stranded wires will make the slide switch connections a bit more flexible. The slide switch is wired to the pinouts on the PowerBoost 1000C. The clips in the enclosure will hold that slide switch in place. You can adjust the length of wire from the Qi charger so it neatly fits inside the enclosure. The cable from the battery is inserted through the back and connects to the JST port on the PowerBoost. The cover is secured to the enclosure with number 256 machine screws. You always want to check your circuit works before closing it up. The mustache kind of looks neat, but you can always customize the design to match your style. The PowerBoost 1000C features smart charging, so you can plug it in while you're charging devices and the battery. The slim enclosure really makes it nice for traveling, and it fits really good in your pocket. Thanks so much for watching, and be sure to subscribe for more 3D printing and electronic projects from Adafruit.
Okay.
We're back.
Here's one more.
Oh no.
Yeah. So now we are all caught up after
Okay,
this.
after this one.
We're all caught up with our 3D printing videos. Ready? This is a fun one.
Triple threat.
In this project, we're 3D printing Link's Hylian shield from Zelda. It's over 450 millimeters long and features a built-in handle. It also prints in just 2 parts. The bottom part is printed upside down with support material so that it's easy to remove by hand. You can download the design and customize the parts so that it can fit your 3D printer. The 2 parts are joined in the center and held together by wooden sticks. Be sure to check out the guide on the Adafruit Learning System for a full tutorial. To add color to the outer frame, we'll use masking tape to cover the inner artwork. You can use a hobby knife to cut the masking tape to cover the details with curves. Chrome and blue metallic spray paint are going to give these parts a car paint job finish. Apply at least 2 coats of spray paint to the outer details, making sure to get all the edges. Let the parts dry for an hour before removing the masking tape, and you can use tweezers to make it a lot easier. To start the next color, apply masking tape over the outer frame. You can use blue metallic spray paint for the inner details. After another hour of drying, you can remove the masking tape to reveal the final paint job. To make the Hylian crest and the Triforce stand out, you can use NinjaFlex filament to print these details in different colors. So there you have it. Now you can build the shield to go along with the sword. Be sure to take this, it's dangerous out there.
And we're back. Okay.
Okay.
So now we're all caught up with
We're caught
3D
up.
printing stuff. All right. Don't forget Noah and Pedro at 3D Hangouts tomorrow, 3 p.m. Eastern Standard Time. I got one bit of Pi news. This is really exciting. Make sure you go to raspberrypi.org and check this out. AstroPi is happening. There are people that are going to be doing projects, writing code, and it's going to go to space.
This is like the space-themed show.
Yeah. And so this is the AstroPi. And your projects could make it on there. And they have like a real live astronaut.
I don't understand. Why does it have to be in such a big enclosure?
I don't know. Maybe it fits into a thing.
Clocks into something? Yeah.
Okay, Lydia. Before we go on to new products, let's just do the code. The code is Mouser, celebrating
Mouser.
in the Mouser store.
If I had a cat, calling the cat Mouser would be kind of like,
Yeah.
that was a good name.
Future cat names are Mouser and Gerbers. We called it on the show. We called
Gerbers is like totally taken.
We called it.
We really want to name our next cat Gerbers.
Okay, new product time. Here we go.
Okay.
Zoom. The first ones we'll go through really quick.
Yeah, they're super fast.
Okay, so this week we have the multiple issues of Magpie, the best, longest running Raspberry Pi
This is like the
magazine.
official one too.
This is the official one. It's made on a Raspberry Pi for Raspberry Pi enthusiasts, and it is fantastic. We're the only supplier in the
Look,
U.S.
this one's space
of
themed
these.
too.
Yeah, I guess I can. We're the only supplier in the U.S. So for the people who want to get these, so they don't have to get them all the way from the U.K., you can order them. From
Yeah, it
us.
even says you can get them from Adafruit on the back. Sweet.
Yep. And the other cool thing, I think they still say it too, is they're proud about this. This magazine was made on a Pi.
Yeah. They use a Raspberry Pi to make it. And it's actually like a really nice magazine. It's got a lot of projects.
Yeah.
It's nicely printed.
So a $35 computer can be good enough to, work on magazine stuff. Okay.
Yeah, it's like product advertisements. Anyways.
Next up.
We have all the latest issues
We have
now.
a couple cases. These cases.
These are for the BeagleBone Black.
Yeah, they come in black and they come in silver.
And we have these. We had a similar case for the Raspberry Pi. It was really popular. And these are like really beautiful cases designed in France. And they're anodized aluminum. And we have a silver one. We don't really.
Do you mind if I try to mess with the
Okay, let's mess with the overhead.
Yeah.
I'll
This is
explain
so
it.
deadly what I'm about to do.
Yeah, this might all catch on fire. All right, so they have these beautiful cases, and they have these like really nice acrylic tops in clear and silver. Sorry, clear and smoke, and it's just like a really beautiful case. You want to try it?
Yeah, I'm gonna try it. This is really dangerous, but I'm gonna do it anyways.
Oh, it worked.
Whew, that was scary. Okay.
Okay, so hold on, I gotta do this thing, and then I'm gonna do the lock. Okay.
Yeah. Okay.
Sorry, that was not expected, so clean up some space. And you get a bunch of tools with it. You fit your BeagleBone Black in here. There's some nice standoffs. It's a very nice aluminum case. It even has bumpers on the bottom. And then we also have a version which is like dark version, which is black with like a smoke case top. It's not completely transparent or opaque. It's kind of this translucent smoke color. And you can see the BeagleBone fits very nicely into it. It's great for BeagleBone Blacks because it has the all the slots that you need for like the HDMI and stuff. They're just really lovely cases. I like the Arduino version of this case, and so we decided just to pick up, sight unseen, the BeagleBone Black version as well. So super gothy.
Okay. Next up.
Okay.
It's a segment of the show I like to call Blind Fill.
Yay!
And, this is when we
That's
turn on
Blind Fill.
lots of bright LEDs. Now this isn't too crazy bright. So let's see what happens here.
This is a flexible.
That's nice.
Yeah, it's nice. This is a flexible matrix of 8x8 NeoPixels. So anything that can control NeoPixels or WS2812 or 2011 LEDs can use this. I'm just running like a matrix demo. It zigzags, like it's actually one strand of LEDs that zigzag all the way around. And what's nice is that it's on a flex PCB, so you can kind of bend and twist it. Much like all the other flex PCBs that we have this also in 8x32 and also 16x16. This is the teeny one. These are probably really good for wearables because they're flexible, so they're not going to be sharp and pointy and like ow, because they will move with you. However, these are not designed for repeated flexing. They will eventually crack. Flex PCBs were meant to be bent around a shape and then kept that way, like in an enclosure or something. They're not actually designed for repeated flexing. So you can, but we don't warranty it. So like be super careful. Don't try to bend it too much. Don't have a lot of repeated flexing. And if they crack, you might have to replace or solder the LED to repair it. But other than that, it's a beautiful and flexible LED matrix.
Okay, next up.
Ooh, it is a humidity sensor. This is a TI HDC 1008 humidity sensor. They have two versions, the 1000 and 1008. 1008 is a lot cheaper, and the precision isn't that much different. It's like 3% versus 4%. So you went with the 4%, but it's a lot less expensive. And this is like the least expensive humidity sensor for the precision. Like you can get a DHT11 or DHT22, but they're not nearly as precise as this one. This has like 0.2 degrees centigrade temperature precision and like 4% precision on humidity. What's really nice about this is I2C. You can have up to 4 on one I2C bus because you can change the addresses. You can have 4 different addresses. And it's both 3 volt and 5 volt safe. So you can use it with like any microcontroller. You certainly don't have to worry about level shifting or anything. Works with 3 volts, works with 5 volts. And I even have a little demo to show over here. Hold on, let me set this up. Push this out of the way. So the demo I have here is I've got the breakout here connected to a Metro Arduino compatible. I have this little LCD which is showing the temperature and humidity. And if I go like this,
well, it works.
The humidity goes up because I just breathed on it and made it very humid. What's neat is the sensor is actually on the underneath of BGA chip. So while it's not like waterproof, like if you dunk in water, definitely not going to be happy about it. But it is protected from like debris and from like top oxidation and from getting stuff on top. A lot of times the sensor element for a sensor chip is on the top, but for this one it's on the bottom. So it's kind of, it's just, there's enough space between the bulbs of the BGA to get air through, but not so much that you have to worry about stuff scratching it or stuff getting in. So it's a nice solid state sensor. You can also heat it up by putting your finger on top of it. It's a very nice temperature sensor as well. Really easy to use. We have Arduino code for it, but it's probably trivial to port it to any microcontroller you like. And it's a nice chip from TI.
Okay. And last but not least, we got some more LEDs.
Yeah, this is the LED Magician. And this is an interesting product that a Singaporean magician, I guess, LED electrical engineer, emailed us, and I was like, this is an interesting product. So I have a demo that I'm going to show for you. Maybe I'll have my assistant, Mr. Lady Ada, help me out. But this is the board you get. You get this thing. And this is basically, like it's a PIC microcontroller. It's basically like an Arduino or a microcontroller that's pre-programmed with a bunch of LED effects, and it has high output drivers, so it can drive like LED strips that are like 12 volts or like big collections of LEDs. It doesn't do digital LEDs, it only does like analog LEDs. But what's nice about it is it has all the programming done for you, and it has a lot of like really common effects. So if you need a certain kind of effect with a microcontroller and LEDs, LED strips, and you don't want to program, this one you just kind of like solder, connect, and you're ready to go. And it's like super easy and fast. And I thought that's kind of like useful, especially for like costumers or prop makers who want to. Whoa, that's really bright. Who want to like have effects without programming. So what's also nice is down here, there's LEDs on the board that mimic what the output is. So that's like really nice. So let me see. I can do what? So there's different effects. So here's a different effect. It's one of the effects. Whoa, super bright. Let's do another one. It's another effect. So there's like 30 or something effects built into this. Sorry, it's so bright you're dying, huh?
It's okay.
And I think you can lower the speed or brightness or something. So yeah, it does a bunch of different things, and there's like an animated GIF, and also on the product page, I think go through all the different effects that you can do. But I like it. I think it'll be really handy for people who are doing props and want to blind fill and don't want to do any programming, especially for like, oh, I want just like a like a marquee, and I just want the LEDs to do something. So this could be a good helper for your props or theater or costuming.
And with that, Lady Ada, guess what that was?
New products?
That was new products. Good
Yay!
work. Okay, we're done. All right. Before we get going on, we're going to ask some questions. We're going to answer some questions. Sorry.
Yeah, I don't have to ask a question. Are you kidding?
Yeah, this is asking a germ. Code Mouser, 10% off all the way till 11:59 p.m. Eastern Standard Time tonight. A reminder, we are not venture funded. We do not have a parent company. We are not a publicly held stock. We are only and solely supported. We don't take advertising. We don't have sponsors. We are only and solely supported by your orders. So
the viewer.
If you want to see this Adafruit open source hardware experiment going, keep going. Pick up something once in a while, because it's kind of scary out there.
It's a mess.
Yeah.
It's a total mess.
We're doing okay. So thank you. It's working out. The lights are still on. Everything's good.
Yeah, we just had a big build out too.
Okay.
We're doing it.
So we're going to answer some questions.
Give me the questions.
Yeah. So it's question time, folks. Post your questions up in the chat. We'll get to all of them as fast as we can. And here we go. The first question. Hello from Boston's Learn to Teach, Teach to Learn program. The
Hello.
teen youth teachers from Handy Device, Cool Laser Cut Robot Cam, want to store and call code for different gestures on an SD card. Adafruit's Ethernet shields are on back order. Is there another shield they can use with their Uno with SD card? Is there another Arduino approach that they can take to do this? Oh, I have an idea. So they want to store different gestures. Can't they use the servos that maybe you have? That,
Well,
like,
if they already have if they're using like a handy board, they already have the program in it.
Yeah.
We have a data logger shield that has a real-time clock and an SD card slot on it, and it works great with an Arduino, any Arduino.
Yeah, that's in stock. So you could
We have this in stock.
You could store the gestures.
Yeah.
And then query it and get it out.
Yeah, and we have example code. It works with the SD library, and people love them, and they use large size SD cards, which can be handy because those are the most popular. So check out the data logging shield.
Okay. The previous product that you showed, the LED Magician, is it compatible with RGB strips?
Well, you can use RGB strips, but it only does one channel per, so you would have red, green, blue. Do you know what I mean? Like each channel only does one LED. It only does one PWM channel, and it's not compatible with digital LED strips. It's only so it doesn't work with NeoPixels or dot stars. It's only good for use with analog LEDs or analog LED strips.
Okay. What do you think of the new ham radio shield? Any interest in getting products like that? I haven't seen the ham radio shield yet.
I don't know.
I'm gonna look it up.
Send it in. We'll blog it up.
Yeah, I'm gonna look it up. Next up, any ideas to support the Bosch BME 280 humidity, temperature, and pressure?
Yeah, we have a breakout for it. It'll be out probably early next week,
Okay.
and we'll have code for it too. It's not a very difficult to use sensor.
All right. I need a matrix lighting board, 6 by 9 inch, that looks like dripping blood. What can you recommend? Thanks. It's cool. 6 by 9, so it'd have to be the high resolution enough. I mean, we have panels that could kind of look like dripping blood.
We have. I'm not sure if the panel itself is covered in blood. If you just want the LEDs to display like they're dripping blood, we have the 32 by 64 RGB matrix panels, and they come in like multiple different sizes. And there's one that's about like this big, and they even come even smaller. They're not like 6 by 9 because they're 2 by 1, so it would be 4.5 by 9. But you could use that with like a Raspberry Pi. We have a RGB matrix hat, and just play like a white code that would display dripping blood on them. I don't have a dripping blood example.
Yeah.
I don't have that, but it's something that you could do.
This person says, I want to get into 3D printing, but I read about issues with fumes or nanoparticles in the air. I would suggest email the 3D printer manufacturer and ask them what they suggest. They might say, ventilation. They might say it's good practices to have, don't be in an enclosed box, generally speaking.
Yeah, you could put it near your window and open the window, or have a fan that would blow it out. It does have a scent. You can smell it, but it's not a strong scent. And the things that you're printing don't. I think especially PLA, it's a corn-based plastic, so it's not. ABS is definitely more toxic than PLA. I don't know how the MSDS for PLA. You can actually read the.
Contact the manufacturers. They probably get this question all the time.
Yeah, that's true.
Next up, Total Noob here. What does the prototyping boards for the Raspberry Pi allow me to do?
Prototyping boards for Raspberry Pi allow you to make a custom circuit that you use components that you'd buy, like LEDs and resistors, capacitors and buttons and sensors, and you'd make a custom circuit without having to make a circuit board, which usually takes a little bit more effort. Instead, you would be using wires and you would just solder them together onto a grid, which would be kind of a way of mocking up your circuit.
Okay. Someone had an earlier question about MIDI and Python. I can't really search. Oh, here it is. Okay, is there a good Python module that reads MIDI data from Pi's USB port? I want to connect a MIDI controller and play notes out of the 3.5mm jack via Python.
There probably is something that can read the MIDI data from USB MIDI on Raspberry Pi, but I've never done it. So I don't know, but there is a USB MIDI standard. So as long as whatever you're using fulfills the USB MIDI standard, there's a standard for it, like a mouse or keyboard or whatever, then there's probably software for it. I just don't know. But it seems like something somebody would have done.
Okay, and that is it for questions tonight. Good work. We're going to do a trivia question, and then we're going to get out of here.
Bag. Yeah.
Yep. Okay, trivia question, Lady Ada. What are the rules?
Rules are, if you've won a prize from this show before, you can't enter again. We have only one winner per my lifetime for this show. So if you've won something from the Ask Engineer show, please don't even think about type. Maybe just go look at some cat videos. The prize today is an HDC 1000 humidity sensor.
That's a good prize.
It's a great little humidity sensor. I love it, and it's our new product of the week. What's the...
The question is, what is the name of the spacecraft that took the first close-up photos of Mars in 1965, July 15th?
We talked about it earlier?
Talked about it earlier.
Put
what is
in
the
the
name of the spacecraft?
Into YouTube or Ustream.
Yeah.
Whichever one we see first.
The answer is not 42.
No.
Let's see who gets it first. Spacecraft.
It's also not Neil
July
deGrasse
15th.
Tyson. I know it sounds like we might have shot him into space, but we didn't.
No. 1965.
Flyby spacecraft.
All right, Chuck Lamhorn. Congratulations, Chuck. Mariner 4.
Nice work, Chuck.
Ding, ding, ding. All you had to do is actually watch the show.
You win an HDC 1008 humidity temperature sensor, which is so useful and handy. I'm sure you will measure all sorts of humidities with it. Congratulations. Email support@adafruit.com and say, hey, I won the HDC 1008 temperature humidity sensor on the show, and we will send you one.
All right, that's it for the show tonight. Thank you, everybody. We really appreciate it, you stopping by. We are off next week, most likely, but I'm planning for us to.
That's true. I mean, like anything can happen.
Anything can happen
But
anytime.
our plan is not.
Yeah, once in a while during the summer, we take a couple shows off. So we'll be off.
Break.
We'll be off next week, but we'll see everybody with a big, amazing show the week after. Thank you, everyone. Once again, don't forget the code is Mouser. 10% off on the Adafruit store all the way up to 1:59 p.m. Eastern Standard Time tonight.
And if you don't want 10% off, you can just go to Mouser.
Yeah.
They do have nice free shipping.
Special thanks to all of our Adafruit people that are here, also working remotely. They're helping out with stuff. Special thanks to all of our customers, community, friends, all the folks that keep Adafruit going. Thank you so much. We'll see everybody next week. Here's a picture of MOSFET. And here is your moment of Zener.